Welcome to this webinar. How can BIM help tackle construction's productivity challenges? I am Thomas Lane, technical editor of Building Magazine. Productivity has long been a challenge for the construction industry, with a lack of technological advancement, miscommunication, coordination issues, and inefficient use of time, just to name some of the reasons given for this problem. On top of this, we've got COVID-19 layered over it. So the last 18 months have been very, very difficult. We're now being particularly challenged by issues around labour shortages, which don't look like they're going to resolve themselves anytime soon. So the imperative to actually address the productivity issue has never been more important. So to discuss how the industry could address these challenges using BIM, I'm joined by three panelists. So I'm joined by Anna Fiektek, who is an architect and BIM manager of the Architect Orms, Ben Huskerson, who is Chief Digital Officer at Gleeds, and Carl Johnson, who is a technical marketing manager for BIM and MEP for Hilti. So in the terms of the way this will work, we will hear from each of our speakers in turn. Each one will give a presentation lasting maybe about 10 minutes each. And once the formal presentations are over, it's your opportunity, the audience, to put your questions to our expert panel. And we will have however long is left, maybe 15, 20 minutes to take some of those questions. So in terms of the running order, Ben will go first. He's going to talk about how BIM enhances Gleeds' value proposition for construction right through to building operation. Anna will speak next about the benefits of BIM, but also some of the challenges as well, including the increased resources needed to leverage those benefits. And finally, Carl will look at promoting collaboration by linking the design and construction process in a bid to improve productivity. So without further ado, I'm going to hand over Ben, who will kick off our presentation. So thanks very much to Ben.
Thank you, Thomas. Thomas, can you tell me when my slides are visible?
Yep, it's all there. You're ready to go.
Okay. So this afternoon, I'm going to tell you how BIM is enhancing our productivity, enhancing our value proposition, and enabling our digital transformation. Slides are frozen. So very quickly, I'd like to take you through BIM and the place it has in Gleeds' value proposition, the BIM dimensions that we're embedding into our core services, and how BIM is going to play a very important role in our digital transformation. So I've used a simplified Wardley map to visualize how we are progressing our value proposition at Gleeds. And what we're trying to do is obviously move from commodity and product-based proposition to more custom-built and Genesis zone for our clients. And the ultimate objective is to constantly add value for our clients. And BIM is an extremely important piece of our jigsaw to be able to do that. It's an essential process and technology for us to digitize and to organize our information and data to deliver our services to clients. And as you can see, we're custom building BIM services and linking it to machine learning and basic artificial intelligence with a view that we move towards digital twin, blockchain and deep learning, which I'll talk about in a minute. But before I do that, I'd just like to take you through the simple dimensions that we are using to augment what we do and make us better and make us more efficient. So the BIM dimensions that we're embedding into the core services are 3D, 4D, 5D, 6D, and 7D. And I'll very quickly now take you through what I believe the benefits of each of those are. So 3D, we all know, it helps visualize a project, and it helps us mitigate design and construction errors through a spatially coordinated design, which I think some of the colleagues are going to talk about. But at Gleeds, what we're doing is we're increasingly using VR and AR to visualize our products and our services, and that's really helping communications. In terms of 4D, again, we're linking models to our programs, and that's helping us to optimize construction sequencing. It's helping us to work with contractors and clients to plan construction activities, and it's helping us prevent logistical issues, which again, in the current climate, is an extremely important tool. In terms of 5D, we've been using 5D cost plans for a while now, and it's helping us enhance the accuracy of our cost plans. We can automate quantity takeoffs directly from the models. It's allowing us to give clients real-time cost visualization, helping us notify and visualize the changes of cost if there's a design change, and it's helping us with the cost reporting and budgeting. In terms of 6D, this is without doubt helping us facilitate sustainable and energy efficient asset management, and it's helping us to more accurately plan energy consumption. And I think that's going to improve the more we start to link it with digital twin, et cetera, et cetera. But it's also enabling us to embed information about manufacturers, installation dates, maintenance schedules. It's helping us to configure how to optimize performance and energy requirements, and depending on what sector we move to, how we decommission that information. And in terms of F7D, again, we're using this more and more with our life cycle services and providing FM status, manual maintenance and operation manuals, warranty information, technical specifications, and cleaning schedules. And we're increasingly looking at ways that we can link 6 and 7D to the new technologies that are coming in into the industry. So BIM is absolutely essential in our digital transformation. And I've said it's a process and technology which helps us digitize and organize our data, which is enabling us to convergently augment project management, asset management, cost management, and building surveying. And it will be essential for us with our divergent augmentations of new products and services, which will be linked to digital twins, modern methods of construction, artificial intelligence, and the Internet of Things, and blockchain. Thank you, Thomas. And I'll hand over to my colleagues, I'll hand over to my fellow panelists for their presentation.
All right, well, thanks very much, Ben. But before we move on, just to ask you one or two questions. So, I mean, obviously there's a lot of benefits of BIM, but I mean, to what extent have your clients at Gleeds adopted these technologies?
I think the reality, there's definitely a difference between public sector and private sector. And I have a remit, a global remit, and there's absolutely a difference of adoption of BIM and awareness of BIM, depending on what part of the world that we're operating. But what I can say is the awareness of BIM and the awareness of the benefits of BIM is absolutely increasing. And clients are beginning to ask us to use BIM because they do see that it can reduce time, cost, and quality. So I would say that the appetite for BIM is absolutely accelerating.
I mean, would you say it's obviously I guess it's been picking up over a number of years, but would you say that the sort of current issues around sort of, I guess, well, you look at HG driver shortages, and also you mentioned logistics in your presentation, but also the need to be more productive. Would you say that's actually given BIM a new impetus?
Like I said, I look after digital transformation, and we've been working on digitally transforming the construction industry. As we all know, it's fragmented, it's transient, we don't capture lessons learned. And the one thing that the pandemic has done is accelerate transformation. And like I've tried to say in my presentation, I see BIM as an essential component to transformation. It's certainly an essential processing technology that's allowing us to convergently augment what we do, and when we start to look at creating new products and services.
Okay, well, great. Well, thanks very much, Ben. So we'll move on now to our next speaker, and that is Anna Fitek from Orm. So over to you, Anna. Thank you.
Can you see my screen? Okay.
Yes, I can. If you could maximize it, I think you've just done that. So that's perfect. Yeah, brilliant. Thank you.
Okay, so I'm Anna. I'm a BIM manager at Orms. I'm also a qualified architect and have been with the office for over 10 years. We are an award-winning architectural practice of 70 people with expertise in new build and refurbishments. We work on offices, hotels, residential, leisure, master planning, and school projects. We have started implementing BIM in 2011, and currently all our projects are developed in 3D from the very beginning and embrace BIM workflows. We were awarded ISO 19650 BIM certification by BRE earlier this year, and we are one of the very few architectural offices to hold it, and we are proud to be recognized as BIM experts. Similar to previous panelists, to us BIM is a clear winner. We don't do any projects in 2D anymore. This is because we see many benefits to BIM and think it's a better and smarter way of running projects and delivering better value for our clients. There are multiple studies suggesting that BIM is delivering cost and time savings, as well as improving quality of design when we look at the whole process, including constructions and handover. However, at present, this doesn't seem to be the case when we look at the design stages of the project, which is what we work on, what we are involved in. So for architectural practice, in general, we spend more time on design and coordination. We need more people allocated to projects from early on, and the cost of running in projects is higher for our practice. However, we see improved quality, we see improved communication and risk management. Our projects are larger and more complex, and we produce more information in general. We can also analyze our designs to a greater degree, and we can provide more added value to the clients, contractors, and FM teams, which would not be possible without BIM. So in terms of time, when we moved from 2D to 3D and then BIM, this affected us in many ways. So in general, we can see a few things that we can do much faster and better than in 2D. For example, our plans, sections, elevations don't need to be manually updated and checked. Our renderings always match our drawings as we use our BIM models to do that. We also have the ability to create VR, virtual walkthroughs, and animations that are now straightforward and quick to create. Also, thanks to digital collaboration tools, we can raise design issues easily and track them in a cloud. This is, of course, much better way and much faster than what we used to do in Excel. We also see fewer RFIs and problems on site if we use cluster detection from early on. However, to get those benefits, we need to spend more time elsewhere. For example, we coordinate better by using clash detection. That saves time on site, but it takes time to model the building to a greater degree and to fix all the clashes that we wouldn't even know we had if we were working in 2D. And while CGIs are easier and faster to create, we make more of them and we spend more time on design and analysis to make the design better. And when it comes to the design changes, it can go either way. Some changes are easier done in BIM model, with all drawings updating semi-automatically, while other changes are much faster in 2D, where you don't have to deal with all the complexities of 3D model. And then on BIM projects, where clients ask for data to be included within the models, we need to create proper BIM documentation, including BIM execution plans to ensure that we can deliver what's required. So input of asset data is a relatively new requirement, and it's another time-consuming task that we carry out for the benefit of our clients. Another thing are information sign-offs that we try to implement as per ISO workflows when we use common data environment. So all of this takes time, and on many projects this requires additional resource of document controller. So as you can see, for an architectural office, more time is required to deliver BIM projects in comparison to non-BIM projects. However, our quality improves. We now deliver better buildings. We more carefully analyze them and consider in more detail from the very beginning. We can do solar analysis, carbon assessments. We take off quantities from the models from very early on. Because we model everything from the beginning, we can spot issues early and start looking at the design problems and opportunities more holistically. And it's much easier to explain our designs using models. Common data environment, clash detection, renderings, tools for managing design online to keep track of ongoing issues. All of those help with reducing risk of changes and delay on site and improve quality of the building. So BIM definitely improves our communication and improves quality, but overall it can be a complex process requiring a lot of training and management. When it comes to cost, it costs architects more because we need to spend more time delivering data and managing large amounts of information that we didn't need to do in 2D. BIM software is much more expensive than 2D software. We are now at the point where 1 year subscription for one user costs the same as perpetual license used to for 2D package. And when we did move from 2D to 3D, the cost doubled. Also, staff training takes longer, and for our size practice, we need support of BIM staff and document controller, and on some projects, we also require BIM coordinator who ensures compliance with EIRs. And there's additional software that we didn't need before, starting from multiple BIM model software add-ons that enable us to work faster, clash detection software, and CDE platforms that are subscription-based. So BIM costs more at the design stage. However, there are a number of studies that suggest that this cost is paid back many times over when looking at the overall project costs, including construction and handover stages. Another difference we see between 3D and 2D workflows in our practice is about resources allocation over time, which in principle is matching this McLeamy diagram that you can see here and probably seen many times before. It shows that we put more effort at the beginning of the project. This is because we need to capture existing data in BIM models, we start developing design, evaluate options, and later on, we spend more time coordinating the design to a greater degree. However, on this illustration, it looks like the amount of effort is the same for BIM and 2D, and that effort just shifted to the front. What we actually see in our office is that 3D and BIM projects actually require more resource than 2D jobs used to. So from our experience, it looks more like this image. More effort at the beginning can result in fewer RFIs, fewer problems on site, easier sign-offs of contractors' proposals. And that effort also pays off in terms of risk management and quality of work. And we see that BIM enables us to work on bigger projects for more ambitious clients. So all that work that design team does is just a part of the picture. There are studies showing that this additional effort brings benefits in terms of time and money to the contractor, client, and FM teams, and adds value in the long run. Tools like common data environment, clash detection, 4D construction, they all should help with delivering buildings on time and within the budget. And also, when looking at prefabrication and modern methods of construction together with BIM, cost and time benefits can be much greater. In addition to that, new technologies, including semi-autonomous robots on site that can help with construction, accuracy, and progress tracking, all can help with saving time and reducing construction costs. BIM models are also a great tool in evaluation of health and safety risks and devising ways of minimizing them. If there are no accidents, there are fewer delays. BIM models are making it easier to deliver buildings on time and making them safer to build and to use. Renderings, walkthroughs, animation, construction drawings with 3D views on them all help people to understand the design and improve communication. Online tools for managing design issues help to keep track of design development and make it easy to collaborate and solve problems as a team. Use of common data environment can improve communication by ensuring everyone is using the right documentation. So all those greater design analysis, improved communication and collaboration, and collection of additional data should lead to better buildings. Homes, as a practice leading in sustainability, can understand many other benefits BIM and technology can deliver to clients. For example, if asset data is specified as a deliverable, it can be used for whole life carbon assessments and whole life cost assessments. This can deliver further efficiencies while building is in operation. However, what I find really interesting and think we'll see more over coming years is looking at the efficiency within the whole building life cycle and circular economy, and how data collected in BIM asset information models and digital twins will be supporting this. Thank you for listening.
Great, thanks so much, Anna. You were breaking up a little bit towards the end. I hope everybody could hear you okay. Before we move on to our last presenter, I've just got a couple of questions for you. The first one's coming from actually from one of our listeners, Jeremy Alley, and he's asking you how you became a BIM manager from being an architect. I mean, did you need to do extra sort of training or extra levels of certification needing, or was it more about sort of the fact you have the knowledge already?
I was always interested in BIM. I started my studies in Poland, and I went to one of lectures from ex-Foster employees who were talking about BIM and generative design, and that was like 15 years ago. And from then on, I just thought, yes, that's something I should be doing. And when I go to the UK, probably everyone will be doing it already. So, you know, when I came to the practice and saw actually it's not happening yet, but it is starting to happen. When I finished my part 2, I did my part 3, and I just got so interested in this and thought that that's the way to do it. And like, why is nobody doing it that way? And the practice was going in that direction. They allowed me to train and to start developing my skills while working part-time as architect. And finally, I moved to a full-time role as a BIM manager.
Right, I see. So you're doing it full-time now. I mean, one thing, I mean, your presentation was very interesting because, I mean, a lot of people talk about the benefits and never really talk about the costs. So it's great to sort of see your honesty there. I mean, would you say for Orms that, is it overall a benefit from adopting BIM, or do you think it's actually a bit of, you know, there are benefits, but you're not actually reaping them, other people are reaping them, and in fact, overall, it's a bit of a cost to you as a firm?
It's a bit of both. I mean, we don't see the direct impact on our program. We don't really see benefits in efficiency as you would see on site, as you would see as an FM user. But all those tools allow us to make better designs. We can analyze it better. We can see it better. We do many more options. We just started doing whole life carbon assessments. Like, we wouldn't be able to do all those things without BIM and without modeling all this information. So there are definitely benefits of doing this for us, but they are just different to, you know, the other parts of construction industry.
Okay, brilliant. Well, thanks so much, Anna. So we'll move on now to our last presenter, Carl Johnson, who is Technical Marketing Manager for BIM and MEP at Hilti. So over to you, Carl.
Nice. Could I have my slides, please? Perfect. So yeah, I'm Carl Johnson, I'm Technical Marketing Manager for BIM and MEP for Northern Europe for Hilti. Hilti themselves are a construction product manufacturer, working in 120 different countries and employing over 25,000 people globally. Next slide, please. If we look at why we all started getting on our BIM journey, you know, there was a number of reasons why we wanted to ultimately make our projects better. whether that's through the material control, whether that's through ensuring standards and regulations are maintained, whether that's through productivity, the ability to pull out as-built information a lot faster. There's a number of reasons why we all got involved with it. With productivity, I feel being a key driver. Next slide, please. And I think that one of the elements with productivity where we can start to grow and to drive that forwards is to start to engage more with our supply chain at an earlier stage through design, rather than when we actually get to the construction site itself. You know, we then can start reaping some of the benefits around some of these key topics, such as productivity, such as the material control, such as standard and regulation adherence. Planning becomes a lot easier. We can start scheduling in materials, things like that. Next slide, please. I think when we start then looking at how we engage with the supply chain a lot earlier, you know, there's some key areas where we can already start to look at these, if you like, use cases, where we can start grabbing these benefits. You know, if we start thinking about design optimization, by working with manufacturers and design specialists, starting to optimize how materials are used, so we can then start minimizing wastage. We can plan up front a lot earlier and take advantage of more advanced logistics solutions, being able to get materials to site when we need them, in the right locations, in the right quantities, rather than having to take mass orders or scheduling deliveries in short notice and then finding that, you know, we have issues, as we do at the moment now globally, with material supply. But then by planning it all in earlier, we can then start taking advantage of off-site manufacture a lot more. You know, cutting, kitting, assembly services, all of these things start to not only drive productivity on the construction site, but also help minimize the amount of wastage we have. And again, link back to that whole topic around the logistics, bringing elements in only when we need them and when we're ready for them. Moving on from that, when we start then looking at areas like BIM to field, you know, starting to see more advanced layout tools, more total stations, but then taking the step forwards into construction site robotics as well. You know, and using these tools to not only drive productivity by speeding some processes up, but also by reducing health and safety risks as well, whether that's working at height, hand-on vibration. All these things can all then start to be minimized with the use of some of these robotic tools. When we then start thinking about validation and documenting what's actually been done and ensuring that the work that's been carried out adheres to standards. If we think about facades going up, once the next level's gone up, you can no longer see what fire stopping was carried out at the edge of slab. But if you can document that as the fire stopping is going in and pull that into your as-built documentation, this also then helps not only ensure that what was done met the required standards, but we can also drive that then forwards to the facilities management suppliers as well, and help for the through life management of that asset. And then the whole field to BIM topic, you know, documenting again what was already done on site, but also then starting to look at what we do when it comes to renovations, introducing scanning technologies in order to detail existing structures and bring them into the BIM environment for when we have extensions and such like. Slide, please. Now, when I'm just talking now about the design optimization, one of the key ones that stands out to me is when we start looking at MEP supports. If we could just start that video, please. When we're looking at MEP supports, you know, still
Al, you just need to unmute yourself while the video's on.
sorry about that. When we come to some construction sites, when we talk about MEP supports, you know, sometimes we walk on some, and you know, particularly some of the older sites, it can look a little bit like a forest of steel when we walk down some service corridors. But if we can start to optimize that design and move to a multi-trade service support approach, we can take out a lot of the steel work that's, you know, up in these service areas. We can get all of the trades onto these common supports, so reducing the material, reducing the number of fasting points back to the structure, and it's a lot quicker to put one bracket up than 7. I think we can all agree on that. So these drive some great benefits, but then also moving to this multi-trade approach allows us to then also take advantage of those prefabrication services that are out there in the market, whether it's as simple as getting channel and strut cut and delivered to site the right length so we remove hot works, whether we're going to go down the kitting route or, you know, fully assembled bracketry and getting that to site when we need it for each zone. All becomes a lot easier when we move to this alternative way of thinking. Have the next slide, please. That then also links into fire protection or passive fire protection and fire stopping. Could you start the video, please?
Al, just again, you need to unmute there.
When we move to looking at passive fire protection, there are added benefits where we've had the mechanical and electrical containment all coordinated together on that common bracketry. We can then ensure that the bracketry near the fire seals is fire rated if that's a requirement. But then we can also start planning how these services pass from one area to another and design the fire seals accordingly. Whether that's through standard tested approved solutions or, you know, managing engineering judgments, this all becomes a lot easier when everything there is coordinated. And again, this can all be driven from our BIM models and engaging with the supply chain that much earlier. The next slide, please. And then when it comes to that BIM to field element and the introduction of newer technologies, that we've all seen, you know, total stations from on a lot of construction sites now, but then taking that total station that step further and introducing an element of robotics as well on the construction site not only drives productivity, but also allows us to minimize some of those health and safety risks. Thinking about some projects in particular, if you're introducing elements like robotic drilling, where we can, you know, take drilling for one robot to 5, 6, 7, 800 holes in a day. No operatives being subjected to, you know, the risks of working at height, the inherent risks of dust when drilling, because everything can be done dustless with vacuums fitted to robotics. This again has massive productivity gains. You know, you then have another team coming through fastening the bracketry in place. Is a lot quicker than how we would sometimes maybe traditionally do it. Slide, please. And having the robotics linked via the total stations built into them back to our BIM models ensures we maintain accuracy as well. So everything is as it should be. And the last slide, please. Oh, just finally for me to say thank you for listening.
Great. Well, thanks very much, Carl. It's very interesting, and particularly a bit on robotics. So am I right in thinking that these robotic drills know exactly where to drill? They've got the BIM model somehow loaded into them, and they know exactly where to drill a hole. Is that right?
Absolutely. So much in the same way as you would you'd extract the field points from a BIM model. It's if you're using it for a total station, you then feed that into the total station built into the robotics, and it's also programmed with its start finish locations. And then once you've programmed that in, it knows where it is and it goes off and carries out its drilling tasks.
So the key is when you set it off is getting that exact position right. You put it in the sort of start position, and then it's all relative to that, presumably.
Absolutely. And so you essentially model in its multiple start finish locations, and then we can take all of that from the BIM model, and then you've taken that whole drilling operation to just one person operating the robotic drilling machines.
Okay, and I mean, you mentioned robotic drilling, but what sort of other technologies are you either already applying this to, sort of robotic wise, or maybe sort of ready to launch soon?
That's the first one that we've come up with so far. That's the big one for us. The other elements we're going down the road of at the moment are the offsite manufacturing elements, being able to take MEP bracketry as an example, and being able to either do that in kit form or fully assembled and delivered to the construction site.
Right, and my final question is sort of our interest in the robotic side of stuff. I mean, are these robotic drills much more expensive than just a normal one that you just use normally?
That would be the short answer. When you look at not only the amount of technology that goes into them, but the amount of productivity they bring, yes, there's a considerable difference between an operative with a drill and having it all taken care of for you.
Right, sure, brilliant. Well, thanks so much, Carl. So if I could invite our other panelists to sort of switch on their microphones and cameras, and we can all see you, and we're ready to sort of take some questions. So I'd encourage our audience to submit any questions you've got now, and then we can sort of take these. So to kick off, we've already got one actually, just come through. So the question is how do you overcome data management for successful BIM? Because obviously it's all reliant upon data. There's a lot of data out there. Different companies have got data in different places, and in each company it's also got data in probably all sorts of places. So how do you actually manage all that data successfully to get the real benefits? I don't know who wants to take that one first.
I think I can answer that.
Okay.
The whole purpose of common data environment to be used on projects is to deal with the amount of data that we have, to place all of this in one place. So, can you hear me better now? I can't hear you.
Tom, I think it might be you who's dropping out there.
Until Anna comes back.
And Anna's still there. I think it's you who's dropping out.
Oh, okay.
I could hear Anna fine, but Tom, you dropped out there.
But maybe it's my end. It's hard to know. Sorry, Anna, I couldn't hear. Couldn't actually.
Yeah, I was saying about common data environment, that the sole purpose of using that on BIM projects is to manage data in one place, have all the latest versions available to everyone at hand. You know, it's just so much easier if everyone can just log on to one platform and take what they need. And with BIM, we need to produce many more documents than we used to. So it's really, really useful.
So all your data is within the BIM model. It's not sort of somewhere else. It's sort of all just within that model. So anyone who's got access to the common data environment, that model, has got access to that data. Is that right?
That's part of it, but the common data environment is not just for models. It's for all the drawings, specifications, for all the RFIs, like anything to do with the project, really.
Right.
And Thomas, if I can, Thomas, if I may, I'll just add to what Anna said there. I think a really important role is information management, and having an information manager, making sure that everybody knows what they've got to do when, and what they have to do with the data, with their information. I think is paramount to the success of BIM. And we find having early workshops, just promoting the benefits and how it's going to benefit every stakeholder also is a useful exercise.
Yeah, I would just add to that, Ben, with information managers, I think also another key role they perform is checking that the data that people supply is accurate and it's to the standards that we need them to be. Because it's easy to say you're doing something but not doing it right, and this is just a quality assurance role that will add value to the clients, because if everything's okay in the cloud, then everyone can use it easier and it's all more straightforward.
Absolutely.
I mean, is the information manager sort of specific to the project, or would you all, different specialisms each have one? So Anna, you'd be the information manager for Orms, but Ben, you'd be the information manager for Gleeds, and the contractor would have one, or is it like one overarching person?
We do both. So we provide clients the role of project management and information manager, and we try, we essentially do what Anna's just said, making sure people are doing what they should be doing, and making sure that the information is complete is really, really important. But within Gleeds itself, one of the biggest challenges we've got is organising and structuring our own data. So we have data stewards and information, slightly different, but we have information managers internally as well.
Okay, and I mean, there's been a lot of talk about the golden thread of information. When you look at the building safety bill, and also what Hackett recommended, that every single residential project over 18 meters high should have this audit trail of everything that has been done at the design stage, but you also capture the as-built condition of the building, and it has to go through into operation as well. That data has to be kept for the building's life. Is that, how does that interface with BIM? Is BIM the golden thread, or is another sort of lot of data that you have to kind of keep side by side with all that BIM sort of information?
I think, again, this is about common data environment, where you upload all your information, the drawings, the models, the specifications, everything goes there. And when you update your design, you produce new revisions. They all go on top of those previous versions. So you can always review the history of design and history of certain aspects. So that's your golden thread. So ideally, we should hand over this to the contractor once we finish the design stage. And then once contractor finished, it should be handed over to the client so they can integrate this with their FM systems.
I think that, again, I think the ultimate objective is digital twin. So essentially the client will have a digital representation of their project, and that's when we can really start to do clever things and link in artificial intelligence, machine learning, deep learning, predictive maintenance, and that's where Gleeds are really looking at in terms of 6 and 7D and beyond. But you can't do that until you have a digital twin.
And so, Ben, that begs the question: how do you create that digital twin? I mean, is it something that, it sounds
like we need Anna on most of the projects, and then that's a huge stepping stone towards digital twin.
I think everyone's trying to figure it out at the moment. There are many pilots running around, and there are a few companies who are trying to create digital platforms for digital twins, trying to make the process easier, but it's still kind of under construction. But we definitely need a model to implement that.
Yeah, I think the opportunity really lends itself on where we've got a lot of standardized building. You know, if we've got a building type that's easily to replicate, then you can start to really use the power of digital twin on predictive maintenance. That's something we're doing with a couple of clients, but they're not overly new sexy buildings. They're quite standardized unsexy buildings. But again, the principle's the same.
At ORMS, we hope that digital twins can be applied to any project, not only standardized ones that you mentioned. But we are really interested in sustainability, and we're thinking about circular economy and material passports. And to us, having digital twin to use for managing performance of the building, reducing carbon, reducing bills to the client, and also treating our buildings as material banks so you can reuse them in the future is really important, and it's going to support our sustainable goals in the future.
I mean, that is an interesting point, Anna, because I mean, the whole net zero agenda is just becoming huge, isn't it? And there's a lot of whole life carbon modelling is gaining traction, and the New London Plan requires some projects to have this done as a condition of planning. Now, I mean, are you doing this, and how are you how is that sort of process interfacing with BIM, and how do you envisage it interfacing with digital twins in the future?
We are doing it. We are doing some studies on projects based on our BIM models. So we will take parts of the design and look at facades, for example, and look at different build-ups of those facades and different designs, and we'll try to assess carbon based on that. We have special software, additional software that can do this. We're also doing carbon assessments for the whole buildings, but at the moment, we use BIM models as a checking tool to take off quantities to check, but the current methodology is set by RICS, says we should be using cost plans. So this is what we do to comply with the current standards and procedures. However, BIM models can be really useful in verifying this data.
Okay, and then Ben, this is an area that you are sort of engaged with at all. I mean, your clients presumably must be asking about whole life carbon now, and you need to build that into your processes.
Yeah, the apps, you know, the embedded carbon, we're linking it to our cost plans, so we can do feasibility costs, and at the same time we're looking to be able to do feasibility embodied carbon, so we can start to make informed decisions at really early stage. That's one of the things that we're doing. And then if you go to the other end of the life cycle, again, we're looking at how we can improve the efficiency of a building whilst it's operational. So linking a digital twin to AI and working out how predictive maintenance can start to really improve efficiency and operational efficiency as well. Which all goes to reducing carbon, obviously.
I didn't quite hear the end of that, Ben. I hope you can all hear me now. I'm assuming that you can, so I'll just carry on talking. Basically, so moving on to a question from our audience. Someone's asking whether there's all sorts of software packages out there, different sort of software providers, and I think each of you talked about specialist software, which it works within BIM or accommodation environment. But a big concern is that these programs can't talk to each other. They all speak different languages, and that they may be great on their own, but try and plug it into something else and they're no good. Is this an issue that is now by and large resolved, or are you still grappling with this? You're shaking your head, Ben.
Grappling. I think we'll just leave it as a one-word answer from me. Grappling.
Oh, grappling. Right, you're grappling. But I mean, in this day and age, surely you shouldn't be grappling, should you? I mean, it should be just, really, this should be it sounds like a fairly basic thing that should have been resolved by now, shouldn't it?
I think that there are solutions. There are solutions, but there isn't. I still don't think there's a perfect solution out there. That's my opinion.
Right. Yeah, no, it's a pity. It might help. Do you think it can actually it's going to hold back adoption of these technologies if this is a concern of people? It's a question that's come up, so obviously they're concerned about it, and it might be holding them back from investing maybe in some of the benefits.
I think again, I'll answer it from my perspective and from Glee's perspective. In the very short term, the challenges are there, and I think Anna's spoken about some of the challenges. They exist, they absolutely exist, and we're having to promote the benefits of BIM to clients, and there's a varying degree of understanding, absolutely. But longer term, and if you start looking further down the line, and not that many years away, it's going to be a new way of working. I think the whole EPC role of construction is going to change, and BIM's going to be at the heart of that. And I think that's just going to accelerate the level of investment and adoption of this. But that is slightly longer down the line.
Okay. Great. Well, thanks. Does anyone else want to come in now, or I'll move on to our next question? Okay.
Yeah, Thomas, I think that's a really good question, because you would think that our BIM package software should be really easy and it should be bringing us efficiencies. And I think everyone expects BIM will save them time. As you've seen from my presentation, actually, it's not saving us time that much. It's allowing us to do a lot of different things and good things and improve design, but it's not saving time. A lot of the time we're trying to go around the software, trying to figure out how we get to where we want to get. So I think that's a big thing. If the software could be improved and if it could talk better to other packages, then our efficiency will actually start to increase, and that would be amazing, but we're just not there yet.
That's really interesting. So, obviously you're spending, I don't know, let's say for the sake of every hour you're spending on this, if the software works seamlessly in the way you think in its design really well, how much time would you save, do you think, out of each hour?
It's really hard to say. Even when I was preparing for this, I was trying to understand how much faster we should be getting comparing to 2D, but it's just that the outputs are so different. We are asked to do so many different things now, and put data for the clients, for FM, and do the clash detection and all that. You just can't compare this. So it's really difficult to say, but every little improvement counts, and it makes people more likely to use the software and to use the process. So really looking forward to more investment in that.
I think you've got to look at the entire life cycle of a project during construction. So, and I really liked Anna's diagram, the graph that shows there's probably a lot more time and effort needed in design to get BIM working at the front end, but then the time saving whilst construction's happening improves quite significantly, and so does the cost to change, because the need to change is a lot less. So, from a client perspective, the reduced program and reduced claims, etc., are beneficial. But then the front end work, there's more work. So it's probably hurting the consultants at the moment, trying to force the adoption.
It just seemed a bit tough that someone else is really realizing the benefits further down the line. There's not a mechanism to really sort of distribute that a bit to incentivize people at the front end. A question for you, Ben, from Adrian McCormick. He's asking, how accurate are your cost plan quantities when you take these off the BIM model?
This is not an infrequent question, and the reality is it depends. The accuracy of the takeoffs depend on the accuracy of the model. And I think we've said it before, one of the things that we do independently at the moment is we run traditional checks, we do pivot tables and we check, and some of the times we have to enhance the models as well. So I'm going to go down a really politician type answer. They're improving accuracy, but we're still doing the checking to make sure that the quantities are what we want them to be.
Right, I see. Gosh, is that taking you twice as long then?
Ultimately, we're never going to be in the position where we press the button, the BIM model says X, so that has to be right. We're not, we're going to constantly check and have balances in place. And I think the more that BIM is adopted, then the need for those checks are going to diminish. But at the moment, we do extensive checks to make sure our quantities are correct. And if you just go what Carl was talking about and the accuracy of where the holes are drilled, we do need an accurate BIM model to obviously to do those programming. So I guess, Carl.
Right.
So Ben, do you think that that's something that information managers should be picking up in the future, carrying in the next year?
Yeah, I think that's one of the key roles. That's one of the key areas we see information management going. Yeah, absolutely. And building I don't want to go too much into what we're looking at, but building a platform that allows us to amalgamate lots of different softwares to make the system easier and more slick. That's absolutely what we're looking at. So is it me? Can people hear me, or is it Thomas that we can?
It's Thomas.
It might be me. It's me. So apologies. It's my fault. Sorry, Ben. So I missed that, but I just picking up from what you said earlier on, but the accuracy of of that BIM data, and obviously, Carl, from your point of view, you're drilling holes all through someone's project. These holes are going to be exactly the right place. Are you confident that the model you've got is actually good enough for that?
For the most part, yes. But that's typically because we've been involved from an early stage and we've actually modelled in for instance, the MEP supports ourselves. We've designed and modelled those in, so we're confident that the models we've then got are right. Doesn't always quite work like that, but that's generally when something's been missed out of the model more than anything else.
Right, I see. So that again, does that mean you don't entirely trust other people? Someone gives you a model and says, "Well, can you, what your machines do this," you wouldn't trust it, would you?
By and large, I think you can. Occasionally things get missed, but by and large, the projects that we have worked on where we've brought robotics in, we've not had too many issues of things missing.
Right.
Again, we've been involved at such an early stage on the project that we've been able to collaborate in that model right from the very beginning.
Okay. Well, brilliant. Well, actually, we're actually up to an hour now, which is our allotted time. So that's all, folks. Really. So I'd just like to say thanks very much to our three speakers, and thanks to everybody for listening. I hope you enjoyed today's webinar. And if you would like to hear it again, it should be available on demand later on. Thanks everyone, and have a good rest of your day. Goodbye.
Thank you. Bye.